Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology. So what is the importance of major main parameters of friction, wear and lubrication in this tribology subject? In previous session already we have studied about the friction and the wear. And the also we have studied the lubrication properties and characteristics. So now today we will see the lubrication regimes. So what are the types of lubrication systems are there, and what is the main mechanism of these lubrication systems? We will see. So the first one is hydrodynamic fluid film lubrication or thin film lubrication. Also called as this type of lubrication is called fluid film lubrication. So the main the types of lubrications are one is hydrodynamic, another one is boundary lubrication, and thin film lubrication. The first we will see study about this thick film lubrication. Why it is called thick film lubrication? There is a uh, there is a well separation between one surface to another surface. So in this, the metal to metal contact is completely prevented. Why? Because the sufficient film thickness is maintained between these two contacting surface. I will show you the diagram. The friction in the bearing is due to oil film friction only. The friction occurred, whatever friction occurred in the bearing, that is due to the oil film friction. So viscosity of this lubricant. So whatever you use in the lubricant, the property of a lubricant is viscosity. The viscosity plays a main role in the power loss or temperature rise or flow through the lubricant through the bearing. So it plays a very important role in the power loss or temperature rise concept. If not used proper lubricant, it leads to power loss and then temperature rise, and also the after some time the bearing also will fail. So the diagram shown here, thin film lubrication. See, this is one surface and another surface. There is a separation between these two surfaces with the help of lubricant. So lubricant. So this is there is no metal to metal contact in this thick film lubrication. The principal operation is the aerodynamic theory. So this lubrication can they exist under moderately loaded bearings running at sufficiently high speeds. The main theory is here the aerodynamic theory. It works on aerodynamic theory. I will explain on the later coming of slides what is this aerodynamic theory. So next one is next thick film lubrication shown in figure. The surfaces are separated by thick film of lubricant. So already I told you there is a well separation between two surfaces. The thick film lubricant and there will not be any metal to metal contact. There is no metal to metal contact. That means so the proper lubrication is supplying. So the film thickness is anywhere from the thickness of the fluid film thickness 8 to 20 micrometer. So the typical values coefficient of friction are 0.02 to 0.010. So the hydrodynamic lubrication is coming up under this category. Where is minimum in this case? So the hydrodynamic lubrication also comes under this the category of thick film lubrication. So we in this case the wear is very minimum. So there is no major wear chances in this type of lubrication. Next one is boundary lubrication and also the thin film lubrication. So during starting and stopping, when the velocity is too low, the oil film is not capable to supporting the load. So there will be metal to metal contact at some spots as shown in figure. I will show you. So in this the bearing, see there is a metal to metal contact. So why? Because in starting, so there is no sufficient velocity to float the bearing journal in the inside the bearing. So there will be a chances metal to metal contact. So the boundary lubrication exists also in a bearing if the load becomes too high or if the viscosity of the lubricant is too low. So the mechanical and chemical properties of the bearing surfaces and the lubricants play a vital role. So in this case, the properties already we have learned in previous sessions. So the mechanical properties and chemical properties of the bearing surfaces of the lubricant plays very important role in this boundary lubrication or thick film lubrication. Any lubrication it plays very important role. So in this, see the boundary lubrication, there is a the metal to metal contact. Why? Because that much of lubrication supply is not supplying. So here the surface contact is continuous and extensive. So the lubricant is continuously sticky over the surfaces and provides a continuously renewed absorbed surface film, which reduces the friction and wear. So the typical coefficient of friction in this case 0.05 to 0.20, the film thickness. Next, oiliness of lubricant becomes an important property in boundary lubrication. So the oiliness property very important in this boundary lubrication. Antioxidants and anti-corrosives are added to lubricants to improve their performance. So some additionally antioxidants added lubricants improve their performance. So we can add antioxidants to perform the to perform this mission very effectively. So additives are added to improve the viscosity index of the lubricant. Next, the oilness agents. So the oilness agents increase the oil film's resistance to rupture, usually made from oils of animals or vegetables. The molecules of these oilness agents have strong affinity or petroleum oil and for metal surfaces that are not easily dislodged. So the oilness and lubricity, another term for oilness, not related to viscosity, manifest itself under boundary lubrication. So reduce friction by preventing the oil film breakdown. So next, anti-wear agents. So mild the HEPA additives protect against wear under moderate loads for body lubricants. Anti-wear agents react chemically with the metal to form a protective coating and then reduces the friction. So these agents react chemically with the metal of the component on the body, and to form a layer like the protective coating. So due to its layer, somewhat friction will be reduced. And also called anti-scuff additives. Next one is thin film lubrication. In this, here even though the surfaces are separated by thin film of lubricant, at some high spots, metal to metal contact does exist. So, like shown in this figure. So, because of this intermittent contacts, it's also known as mixed film lubrication. And the surface wear is very mild. The coefficient of friction commonly ranges from 0.04 to 0.10. So this the coefficient of friction, the range is 0.04 to 0.10 in this type of lubrication system. Next, the main mechanism. So what is the importance? What is the mechanism of lubrication? So the lubrication mechanism are classified as hydrodynamic lubrication and hydrostatic lubrication and elasto-hydrodynamic lubrication. So it classified according to the type of load and type of lubrication process, divided into three types. So the extreme boundary lubrication means here under certain conditions of temperature and load, the boundary film breaks leading to direct metal to metal contact, as shown in the figure. So, like in this figure shown, the metal to metal contact and seizure of the metallic surfaces and destruction of one or both surfaces begins. The strong intermolecular forces at the point of contact. So, here you can see it results steering of metallic particles, and here see you soft material and hard material, the metal transfer possible where fragment is there. So in this due to this intermolecular forces, some micro weld you can observe at these contacting surfaces. Extreme pressure agents scoring and fitting of the metal surfaces might occur. Because of this case, scissor is the primarily concern. The scoring and fitting of metal surface is possible. So additives are derivatives of sulfur, phosphorus, or chlorine. So the main additives are uh, derived from these chemicals: sulfur, phosphorus, and chlorine. These additives prevent the welding of mating surfaces under extreme loads and temperatures. These you can reduce, you can prevent the welding of on mating surfaces. So under extreme load and temperatures, these you can add these additives due to the chemical reaction. You can minimize this welding stickiness between the surfaces. Next one is solid film lubrication. When bearings must be operated at extreme temperatures, a solid film lubricant such as graphite or molybdenum disulfide must be used because the ordinary mineral oils are not satisfactory at elevated temperatures. So, those conditions you can use these solid film lubricants like graphite and molybdenum and disulfide sulfide. Clear. So much research is currently being carried out to find composite bearing materials with low wear rates as well as small friction coefficients. So, lot of research is going on this topic. Next, hydrostatic lubrication. So, in this lubrication, it is obtained by introducing the lubricant, which is sometimes air or water, into the load bearing area at a pressure high enough to separate the surfaces with a relatively thick film of lubricant. So, here, uh, so load the pressure of sometimes air or water. Uh, it's sufficient that area at the pressure high enough to separate the surfaces with a relatively thick film of lubricant. So, unlike hydrodynamic lubrication, this kind of lubrication does not require motion of one surface relative to another. Useful in designing bearings where the velocities are small or zero and where frictional resistance is to be an absolute minimum. Next one is elasto-hydrodynamic lubrication. Elasto-hydrodynamic lubrication is the phenomenon that occurs when a lubricant is introduced between surfaces that are in rolling contact, such as mating gears, example, and the rolling bearings. So, in this bearing, the lubrication occurs when the lubrication is introduced between these two surfaces. So, the rolling contact or the mating gears. The mathematical explanation requires the Hertzian theory of contact stress and fluid mechanics. So, according to this theory, you can define this elastodynamic lubrication system elaborately. So, so whenever these two mating gears or rolling bearings are in a contacting position, so due to the that elasticity property of the particular material, there is a lubricant introduced between these two surfaces. That's why this type of lubrication system is called elasto-hydrodynamic lubrication. So now we discuss about the basic concept of hydrodynamic lubrication or thick film lubrication or fluid film lubrication. What is the main mechanism of this hydrodynamic lubrication? So when a bearing is supplied with adequate oil, take an example, the general bearing. A pressure is developed in the clearance space when the journal rotates about an axis that is eccentric with the bearing axis. So this is journal bearing axis, and this is bearing axis, and this one is journal bearing axis. Whenever this the journal rotates about axis, so the eccentric like this. So the axis, there is a eccentricity between these two axes. So the pressure is developed in clearance between these two surface. The load carrying ability of a hydrodynamic bearing arises simply because a viscous fluid resists being pushed around. So whenever this bearing is loaded, under proper conditions, this resistance to motion will develop a pressure distribution in the film that can support usable load. Whatever the pressure developed inside the contact inside the two surfaces, there is a sufficient pressure will distribute to support this applied load. So two mechanisms responsible for this wedge film and squeeze film. Two mechanisms are there for this hydrodynamic lubrication mechanism. So one is the wedge film formation and squeeze film action. The load supporting pressure in hydrodynamic bearings arises from either one or flow of a viscous fluid in a converging channel, the wedge film. The second one, the resistance of a viscous fluid to being squeezed out from the between approaching surfaces and the squeeze film. So whatever you use a lubricant, separate lubricant, the squeezing out from the contacting surfaces. So and another one is there is a formation of wedge shape, so wedge film at this converging channel. These two are responsible for this hydrodynamic lubrication mechanism. We will see one by one, step by step. Here consider a steady load force, a fixed bearing, and a rotating journal. This is a rotating journal, and this is bearing and journal. So there is eccentricity between these two axes. So the load at this condition, at rest condition, the first one is at this rest condition, the bearing clearance space is filled out with the oil. So this one filled with the oil. But the load force has squeezed out oil film at the bottom. Whenever this bearing is subjected to load, there is a metal to metal contact exists. The vertical axis of the bearing and the journal are coaxial. The load and the reaction are in line. The load and reaction force also there. These two forces are in line, and then the vertical axis of the bearing and the journal axis are coaxial. This is at a rest condition. The second stage, when the journal starts to rotate slowly in clockwise direction, like this, clockwise direction. Because of the friction, the journal starts to climb the wall of the bearing surface as shown in figure. In this case, there is a boundary lubrication exists between these two surfaces. So the journal starts to climb the wall. Clear. So the wear normally takes place during this period. However, the journal rotation draws the oil between the surfaces and they separate. So slowly, the first stage there is a metal to metal contact, and the second stage slowly the this starts slowly in a clockwise direction. So what will happen? The journal slowly climb the wall of the bearing surface, and then there is a gap between this surface, journal surface and bearing surface, and immediately the oil fill out between these two surfaces, and then they again separate. And stage 3, as the speed increases, you keep on increases the speed. What will happen? The more oil is drawn in and enough pressure is built up in the contact zone to float the journal. So, so the initial stage, very small amount oil is filled out, and then whenever the speed increases, the more oil is drawn from the main supply, and then the oil filled between these two contact zone, and then there is a sufficient pressure developed in between these two contact surface to float the journal. So at that time, the journal float in a lubricant. So without any metal to metal contact. The further increase in speed, the additional pressure of the converging oil flow to the right of the minimum oil thickness, that is, you can measure, you can represent with H naught, moves the shaft slightly to left of center. So this result, full separation of result, the journal and bearing surfaces occur. In stable operating conditions, the pressure distribution on the journal, as shown in figure, see, at this stage in aerodynamic lubrication, uh, stage 3, in this, there is a sufficient oil film thickness is there. That is called as thick, that is a thick boundary layer, thick lubrication system. So that is mainly that is depends upon the thickness of the film. It's also called as fluid film lubrication, a thick film or fluid film. So the resultant oil film force you can see in this in the diagram, and eccentricity. Okay. At a running condition, the journal float inside the bearing like this. The continuous oil flow also present. So like this, these three types of aerodynamic, three stages are there in a hydrodynamic lubrication system. So this is the main concept of this hydrodynamic lubrication theory. See, in this, the general positions in aerodynamic lubrication, the combined diagram here at a start condition like this, and then start, and then fully running condition. At start condition and then a fully running condition. There is no oil between this oil separation between these two contact surfaces at rest condition, after running start condition, and slowly increasing the speed, and then at a fully speed, the wedge safe lubrication formation is there. So that's why two methods are there, two mechanisms are involved in this hydrodynamic lubrication. One is wedge film lubrication, and then the squeezing. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.